Hello students, welcome back. In the last session, we have discussed what is procedural oriented programming, which is a programming technique based on procedures or functions and calling these functions from main function. The languages which were based on procedural oriented programming were C, COBOL, Fortran, etc. Then we have discussed what is object-oriented programming. This is also a programming technique based on classes and objects. The languages which are based on object-oriented programming are C++, Visual Basic, and Java. Then we have discussed about differences between object-oriented programming and procedural-oriented programming. In today's session, we will discuss some of the basic concepts of object-oriented programming. All the object-oriented programming languages should follow these basic concepts of object-oriented programming. So the concepts of object-oriented programming are object, class, data abstraction, data encapsulation, inheritance, polymorphism. So these are some important concepts or principles of object-oriented programming. All the object-oriented programming languages should follow these principles. So we will discuss these concepts one by one in detail. In procedural programming, we always think in terms of procedures or functions. Say, if a problem is given to us to develop a software to automate college system, we may declare some functions like read student information, staff information, and some other functions to perform some activities. But in object-oriented programming, we have to think in terms of object, not in terms of functions. So what is this object that we will study here? So objects are basic runtime entities in object-oriented system. So these basic runtime entities may represent a person, a place, a bank account, or any item that the program may handle. So these are the real world entities which you can see around you. For example, I may say a bird as an object. I may say a mobile as an object. I may say an animal as an object. So there are many objects in and around us. Each object holds data and code to operate on the data. Or we may say every object has properties and behavior associated with it. So, for example, we have seen an object as a bird. So what are the properties of a bird? The bird may have properties like, you may say, name, then the size or color of the bird. This might be the properties of a bird. And what is the behavior of a bird? You may say eat, fly, This might be the behavior of a bird. Same way, if I say an object has pen, the properties of a pen may be the size again, the color, the company, and the behavior which is associated with this object may be writing. So every object has some properties and behavior associated with it. So what are the objects in a college system? Yes, you may say student is an object. You may say staff is an object. You may say college itself as an object. Then you are right. These can be the objects in a college automation system. Each of these objects holds some properties and methods associated. So what are the properties of object student? The properties of an object students might be the name of a student, the registration number, his address, and so on. What are the methods associated with object student, your behavior of object student here? The methods which are associated with the object student, you may say average and total of the marks. This might be the methods which are associated with an object student. Now look at this example. So this figure is a typical notation used to represent objects in object-oriented system. So the name of the object is student, and the data members which are associated with this object, you can say properties of this objects are name, address, marks. Same way, there are some methods which are associated with this object, that is total and average. So this is object student with its data and methods. As I've said, every object has its own properties, means data, and behavior, means methods in programming context associated with it. And this is a typical notation used to represent an object in object-oriented programming. Remember this. Now you can look around you and you may see many examples of real world objects. Just look around you and you will see the many different examples of objects. Can you see objects around you? Yes. You may say the objects around you or objects around me right now are fan, light, mobile, desk, so many objects around me. So same way you may have objects in and around you. Identify the objects, identify the properties which are associated with the object, identify the methods which are associated with the objects. Okay, what is the data and method associated with object car? If I say an object as car, just try to identify the data and methods which are associated with object car. So do you know what are the properties and methods of a car? Yes, the properties may be the model, the color, and the other properties of a car. The methods which are associated with the car, you may say accelerate, brake, and so on. So these are some methods which are associated with object car. So this is about objects, the first concept of object-oriented programming. Next, class. A class is a collection of objects of similar type, sometimes called as blueprint or template or prototype, from which objects are created. For example, if you want to construct a building, first you will prepare a blueprint for construction or a plan for building. So based on this plan, a building is constructed. Means you are not directly constructing the building, but first you are preparing the plan and then you are constructing the building as per the plan. Same way in object-oriented programming, first we need to create a template or a blueprint. This template or blueprint, it is called as a class. Class tells us what properties and methods should be included in the object. So first we have to create a class, that is a template or a blueprint, and from this template or a blueprint we can create any number of objects. Look at one more example. Suppose we have a class called as car, as I've said, with some properties, say name, color, model and so on, and with some methods like accelerate, brake, etc. From this particular class car, we can create any number of objects. Now look at the objects here. The objects are, say, car, polo, then car, mini, then we have object of class car, that is beetle. Like this we can create any number of objects from a class car. So first we need to have a class, and from that class we can have any number of objects. Now the objects are variables of type class. As I have said, these objects acts as a variable of type class. Here this polo, mini, beetle, all are the variable of type car. Classes are user-defined data types and work like the built-in type of programming language. Now these classes work as a data type, that is user-defined data type. Like we have built-in data types. Now consider a data type that is int. You have a type int, and from this int you can create any number of variables. You may say int of a, comma, b, comma, c, like this. So you're creating the types, that is a, b, c, of data type integer. So integer, here it is a type from which you're creating variables. Same way here in this example, this class car acts as a type or a data type from which you are creating objects, any number of objects you are creating, like polo, mini and beetle. So this class acts as a user-defined data type. Okay, this is about the class. And that's it for today. If you have any doubts, you can write it to me on WhatsApp. Thank you.